Okay, good afternoon. My name is Sarah Dickin. I'm a research fellow at the Stockholm Environment Institute, and I'm sorry that I can't join you today in person. Today I'm going to be talking about the development of a vulnerability framework for dengue using an eco-health perspective that integrates humans, health, and the environment. Recently, there have been a lot of news headlines around the world that have brought attention to the challenges in combating vector-borne disease. But this has not just been a recent phenomenon. Re-emerging and newly emerging diseases are a growing source of morbidity and mortality worldwide. For example, in addition to the spread of dengue, large outbreaks of chikungunya have been reported, and lately Zika is becoming a serious health concern. The expansion of emerging diseases, despite many control efforts, demonstrates gaps in understanding of the complexity of social and ecological systems and how these are managed to promote health. A large volume of research focuses on the characteristics of the pathogen or vector or individual risk factors. However, disease transmission is also influenced by a range of other factors, some of which may seem less direct. To better understand diseases like dengue, we need to consider a range of determinants in the ecological and social environment. An eco-health perspective is one way to approach these challenges. The eco-health approach acknowledges inextricable links between humans and their environment, and the ways that this relationship is tied to health. Ecosystem approaches may involve a range of methodologies, but aim to improve understanding of the complex interactions that determine health. With this in mind, today I'm going to discuss research that developed a vulnerability framework for dengue in Malaysia. I'm going to start by talking about an approach at a national scale using an index and a mapping methodology. Then I'm going to focus in on a local scale using community mapping and local perceptions. In this study, vulnerability is defined as the propensity to be adversely impacted by a health hazard, and in this case, that would be dengue. And vulnerability comprises several components. Exposure conditions refer to conditions that are conducive to the presence of a dengue-carrying mosquito, or conditions that promote transmission within the environment. Susceptibility refers to cultural, social, or economic conditions that render a population sensitive to the impacts of dengue. And adaptive capacity or coping capacity refers to the ability to deal with a health threat or adapt to a hazard. This framework was used to develop an index to map vulnerability. Index approaches are used to simplify and distill complex real-world information into a format that is relevant and useful for decision-making. So this approach was not designed to be a predictive model, but to illustrate how different components of vulnerability interact. So the first step to creating this vulnerability index was a conceptual map of important system components. And so here you can see an example of this, and it might not include all important elements that you might consider relevant, but it shows a range of aspects in the human environment and the natural environment. So based on this conceptual map, a range of data were identified for the index based on what kind of information were available in Malaysia and what was accessible. Next, using thresholds that were identified from the literature, so thresholds identified from modeling studies, thresholds were used to normalize each factor between 0 and 1. Then these were incorporated into an index. So here we can see the different factors that were used to create the vulnerability index. And for the sake of this analysis, the lack of coping capacity was combined into susceptibility. So we can see a range of components, including climate factors, as well as aspects in the social environment. And here we can see in more detail some of the thresholds that were used based on information identified in the literature. And this was to normalize the factors that went into the index between 0 and 1 so that they could be combined together. So here we can see for the exposure component, we have population density, land use, and temperature and precipitation. For susceptibility and lack of coping capacity, here we can see age under 15, type of housing quality, water and sanitation, healthcare access, which is linked to adaptive capacity, and education level. So all of these components were combined to visualize areas of vulnerability. And as I mentioned, this was not designed as a predictive tool, but to highlight interactions between different factors that may not be considered together. So now I'll show some examples of the index outputs. So here we can see two maps for exposures showing seasonal changes. And this information that was used was was an average of climate conditions. So it doesn't represent one particular year, but what would be considered normal conditions. So here we can see a seasonal trend based on the thresholds that were used for the climate factors. Next, for susceptibility, we can see higher susceptibility in red in eastern Malaysia. We can see low susceptibility in Kuala Lumpur and the surrounding region. So next, these components were combined together to visualize vulnerability within Malaysia. And again, here we can see 2 points during the year, so we can see a seasonal trend. We can see that vulnerability increases from 0 to 1, so the red areas are higher vulnerability, the blue areas are lower vulnerability. So areas with high exposure and high susceptibility resulted in the highest overall vulnerability. And these may represent areas for prioritizing planning. Urban environments, especially in the Kuala Lumpur region, are highlighted as vulnerable areas. The seasonal comparison between 2 points in the year also highlights changes in vulnerability due to seasonal trends in climate patterns. And based on the thresholds that were used in this study, we can see that in eastern Malaysia there is heavy rainfall for several months during the year, and this may impact mosquito breeding sites and wash them away. In drier months, exposure in this region actually increases, and this is possibly due to more moderate rainfall, which is conducive to larger mosquito populations. So when this is combined with higher susceptibility, this results in higher vulnerability during this point in the year. In contrast, some areas in Malaysia have consistently low vulnerability. This is due to low exposure, so areas like forested areas, which are not favorable for the Aedes vectors, as well as areas with low population density. We can also see some areas which have zero vulnerability, and this is observed in areas where temperatures are too low to be conducive to mosquito survival, and this is confined to mountainous regions in central Malaysia. But of course, these regions could shrink with warming temperatures. So this type of index approach could be modified using different thresholds from modeling results. And it has been used in other case studies to look at changes over long periods of time, so over 10 years, for instance, to understand how trends in vulnerability are changing. It has also been used to include climate model information to understand how vulnerability might change in the future. So while this national level vulnerability assessment highlights the importance of exposure and how it interacts with susceptibility and lack of coping capacity, it's also important to understand vulnerability at a local scale. Dengue control is a shared challenge for residents because while someone may maintain their property to reduce exposure to the disease, mosquito breeding sites may be found in neighboring houses or public spaces. So now I'm going to discuss an approach to examine local level vulnerability. So the aim here was to apply a local scale mapping approach to identify spatial perceptions of vulnerability to dengue and mosquito breeding areas. Local understanding was compared in 2 different Malaysian communities and was combined to create maps to facilitate community-based and municipal decision-making. The study involved meetings with stakeholders to discuss the project, including public health officials working on vector control, researchers, and community leaders who were interested in the project. So the study took place in 2 locations, Putrajaya, which is a planned city established in the 1990s and with a large amount of landscaped gardens, artificial lake, and wetlands. The second location was in Seremban, which is a more traditional Malaysian city. So community mapping groups were formed in Putrajaya and Seremban, and they were divided into groups of men and women, and this was to encourage gender equity and participation. And residents who participated were asked to draw their local environments and to highlight areas they associated with dengue or mosquito breeding. And then participants were asked to discuss the features on the map to enrich the information found in a spatial format. Next, digital copies were made of the maps, and then information was georeferenced onto a base map. So this process allowed areas identified by participants to be better shared by others looking at the maps, and it also puts the information into the context of surrounding features and areas. And in this format, the information can also be used in other types of GIS analysis. In both Putrajaya and Seremban, residents had a keen understanding of areas where mosquitoes might be breeding in the community. The process of drawing sketch maps highlighted features of interest to community members, rather than containing all aspects or geographic elements. So now I'm going to briefly discuss some of the findings from the mapping process. So here we can see some of the georeference information that was generated by participants in Seremban. And here we can see areas associated with dengue highlighted in red. In Seremban, waste contributed to waste was identified by participants as an important area, which was not a problem in Putrajaya, and this was due to greater garbage removal in the city. In Seremban, groups of empty houses were mapped by participants, and these were reported as places where mosquitoes might breed due to lack of upkeep. There were also areas including empty stores, a stream area that was blocked, a schoolyard, and back alleys between houses, which were linked to dengue because of waste building up, such as used tires. And although construction is not widespread in Seremban, participants reported that foreign workers involved in an upgrade of the sewage system at the time were not aware of the dengue problems, and so they did not properly dispose of plastic containers that could accumulate water. So this highlighted the need for greater community cohesion in Seremban to increase the adaptive capacity to deal with dengue. So this map shows areas in Putrajaya, so associated with, which were perceived to be dengue vulnerable areas. Construction projects, which were frequently occurring in Putrajaya since it was established, were associated with dengue by participants. Several of these sites included residential building sites, as well as abandoned construction sites, due to unmaintained barrels found on these sites, which could potentially accumulate water. Next to the mall, there was a large shipping and construction storage area that residents reported may also permit mosquito breeding. And in contrast to these areas, participants also reported that vegetated areas, flowers, trees, and parks may also contribute to dengue breeding. And this is interesting because the idea behind the large green spaces in Putrajaya is to create a healthy environment. But participants mapped some of these areas and linked them to mosquitoes. In newer areas of Putrajaya, participants also noted that there are less combi programs or campaigns, so cleanup activities to encourage residents to remove domestic mosquito breeding sites, compared to more established areas of the city. And this again shows a role for community cohesion in fighting dengue transmission. Due to frequent rainfall in the region, drainage systems were highlighted as an area of concern in both Putrajaya and Seremban. Drains in the neighborhood were identified in housing areas, especially back alleys and around apartment buildings. The open drains could become trapped with vegetation in the case of Putrajaya or garbage in the case of Seremban, which blocks water flow. A limitation to this approach was that it emphasized the outside environment, and the inside environment is of course also very significant for dengue. Some participants were aware of this and reported areas inside the home, but this was not the focus of the methodology. These kind of spatial perceptions of potential breeding sites have the potential to improve vector control plans. Firstly, they may highlight areas that have been overlooked by regular control activities, but they may also identify areas for further education or awareness building. So areas where there might be discrepancy in perceptions between residents and vector control officials, there may be opportunity to target awareness building messages. And this also demonstrates a more involved role for community members in vector surveillance and a need for greater two-way information exchange between communities and vector control staff. So the findings from this study and comparing between the two communities show that there are differences between Seremban and Putrajaya, even though they are not that far, both cities are not that far from the capital in Kuala Lumpur. So this shows that one approach that's used for vector control in one area might not be appropriate for all contexts, even within Malaysia. So a vector control approach or awareness building strategy may need to be context specific for a particular town or region. There is growing interest in understanding how environmental change and social change is impacting health. So there's a lot of opportunities to continue this kind of work and to better understand the interactions between humans, the environment, and health. Two potential opportunities building off of these studies that I discussed today. Firstly, at a local level, there are opportunities to involve community members in citizen science to help public authorities with their work in vector surveillance. So this could help to increase knowledge of breeding sites among community members and provide a way to target awareness messages and improve vector control activities. At a larger scale, there's opportunity to use future scenarios and development projections. This could be social development scenarios as well as climate change models. And this can help us understand how vulnerability is changing and how it will change in the future in order to respond. So that concludes my presentation today, and I'd like to thank you for your attention. I'd also like to thank the United Nations University for supporting this work. So thank you very much, and I'm open to your questions.